What is fermented food? Basically, it means food or beverages that can be obtained through enzymatic action during the fermentation process. Microbial enzymes such as lipase, amylases, proteases, and rennet are being preferred because it's commercially available and specific. The enzymes that are being introduced in this presentation are rennet, glucanase, and protease, and how it works will be explained to four products which are cheese, bread, wine and beer, and tempeh.
Rennet. Rennet is basically an extract which is obtained from cow's digestive system which is used to digest milk. Rennet contains different types of enzymes and specifically in this part I'm going to talk about chymosin. So the process of making cheese can be divided into two, enzymatic phase and non-enzymatic phase. So this is a step-by-step process of making cheese. So basically milk can be divided into two parts, casein protein and whey protein. So to make cheese we will use the casein part. So casein protein can be divided into is made up of different types of casein proteins, alpha 1, alpha 2, beta casein and also kappa casein. So this alpha 1, alpha 2, beta casein is its internal part and it's surrounded by kappa casein and the entire structure is negatively charged and that is why it maintains a liquid state because it repels one casein protein with another casein protein. It repels. So that's why it maintains a liquid state. So in order for us to form a curd, to form a coagulant, we have to break the negatively charged kappa casein. So what we're going to do here is we're going to add rennet. So when we add rennet into a milk, rennet contains chymosin. Chymosin acts like a scissors and what it does is it cleaves the para-caffeine casein. It cleaves the kappa casein into para-kappa casein and soluble glycomacropeptide. And the hydrolyzed kappa casein can now no longer hold the internal part, okay, and releases it out. That was enzymatic phase, and now we enter into non-enzymatic phase. Non-enzymatic phase happens naturally because calcium ion is found in the milk. So calcium ion will causes all the casein protein released to coagulate together, forming a curd. So this is a non-enzymatic phase. The casein particles now forms cluster of milk proteins, fats, other minerals, and this indicates a non-enzymatic phase.
Glucanases are carbohydrates that hydrolyze glucans, which are polysaccharides consisting of several glucose subunits. In particular, I'll be talking about beta-glucanase as it is the most commonly used in the food industry. In bread making, the addition of beta-glucanase will result in a fluffier and tastier bread. This is because as the beta-glucans are hydrolyzed, glucose is released, providing nutrients for the yeast, and as we all know, yeast aids in fermentation. The shortening of the starch strands will also result in a softer bread, and thus improving the texture. In wine and beer, the presence of beta-glucans in the starting mixture will reduce extract yield as well as cause the mixture to be more viscous. This will make it hard to filtrate as well as cause a loss for the company. A higher percentage of beta-glucans will also result in a hazy beer. Thus, there are two types of glucanases used in wine and beer making. The first one is exo-beta-1,3-glucanase and the other endo-beta-1,3-glucanase. The difference between these two is the releasing product, whereby one will release glucose and the other will release oligosaccharides. The addition of beta-glucanase will result in a lower viscosity, making it easier to filtrate, and also the starches will be more readily available for the microorganisms in the mixture to use for fermentation.
So the protease has the ability to perform synthetic and degradative function. It also has a high yield, less time consumption, less space requirement, low genetic manipulation, and also cost effectiveness. So in the food industry, protease widely used in fermentation processes to produce compound with specific characteristics of flavor and aroma. The tempeh is basically being produced by the fermentation of soybean. So during the fermentation of soybean, there are various microorganisms such as mold, yeast, and bacteria has been found. So the main bacteria has been found is a Bacillus species, especially B. subtilis. So the role of this bacteria is to improve the quality of soybean-based fermented food. Moreover, the fermented with the Bacillus species B4 show high proteolytic activity which enable effective release of soluble protein. The enzyme protease produced by this bacteria is necessary to digest the soy protein, which otherwise easily exploited by our body.
First, milk coagulating, enzyme used to aggregate the milk to form a curd. Second, to increase the sensorial and technological properties such as increase the sweetness. For example, they use lactase to hydrolyze lactose to produce a simple sugar. Then, able to produce lactose-free milk product, which is basically for lactose intolerance. And then for preserved food, next, to enhance the shelf life extension to the product, which is we can store the food much longer. And then lastly, for functional and environmental purposes, which is strengthen the structure of protein and for functional properties.
The first challenge is the extensive research in industrial fermentation have led to great understanding of genomics of potentially useful bacteria. But one of the issues is that how can we utilize this wealth of knowledge to improve food quality and safety? The second challenge is the limitation of available technological tools. For example, certain microorganisms require extreme conditions in order to be utilized in industrial fermentation. Thus, the correct operating procedure needs to be employed in order to ensure maximum efficiency while at the same time to minimize the cost of maintenance. The third challenge is that there is a need to ensure the continuous availability of raw materials for fermentation process.